Hey guys, in this video we're going to learn about the agglutinogens and the antigens that are involved with blood typing. So I'm going to start sharing my screen with you now. It'll be a little slow to come up, but then you'll be able to see our PowerPoint slideshow, which is available on Blackboard. And we're just going to follow along with this, and it'll help us to get orientated for which agglutinogens and antigens we're going to find in each blood type. So first of all, what do these words mean? Now, again, on your test, it won't just say antigen, it'll use this specific term, agglutinogens. So agglutinogens are surface markers that are on red blood cells, and they are antigen flags. And we're going to learn a lot about antigen flags when we get into immune system, chapter 21. But you just need to remember that the agglutinogens are the specific antigen flags that you find on red blood cells. Okay, so these are the specific markers on the surface of red blood cells that give a person their blood type. Now, floating in the plasma of a person's blood, there are agglutinins. So these are antibodies. And these are antibodies that are going to attack certain antigen flags. So these are in the plasma. So your agglutinogens are your antigens. And the way I remember that is the GEN goes together. So antigens and agglutinogens match up, and agglutinins and antibodies are the same thing as well. So let's see what these are all about. So here you have just a test tube of blood, and it's just reminding you that floating in the plasma, you're going to find antibodies. And the correct term for these antibodies that are involved with blood typing is agglutinins. Then on your red blood cells, here's a red blood cell down here, there are little flags or surface markers on the surface. They are antigen flags, and they are called agglutinogens if you're talking about the specific markers that are involved with blood typing. So where do you find an agglutinogen? You find it on your red blood cell. Where do you find an agglutinin? It's an antibody that's floating in the plasma. And whenever you see this Y-shaped structure, that is the symbol for antibody. Antibodies have this Y-shaped structure. So if you're ever talking about antibodies, they usually use this Y-shaped symbol because that's what they look like if you look at them under a really powerful microscope. So here's the chart from your book that tells you about each blood group. So it tells you about A, B, A, and O. It tells you the antigens that are present, the antibodies that are present, and then it starts to talk about blood transfusions. But we're going to break this down into an easier way first, and then we'll come back and look at the chart afterwards. So here's the thing. If your red blood cell has an A flag on it, then this person is an A blood type. So whatever flag is on your red blood cell, that's going to be your blood type. So this person has an A flag attached to their red blood cell, they're going to be type A. Now, the other thing to notice is if you see a second flag that says D on it, if you're going to be positive, A positive, you will have the A flag and the D flag. And then if you're A negative, what will that person look like? Their red blood cell will only have an A flag. That's what A negative would look like. So you're getting the idea here. Whatever agglutinogen flag is on your red blood cell, that is your blood type. So if you are type A, you will have type A flags, type A agglutinogens on your red blood cell. And if you're positive, then you get a second flag, a different flag that's called D. And the D flag shows that you are rhesus positive. So if you're rhesus positive, you have the D flag in addition to your letter flag for your blood group. So if you see an A flag and a D flag, the person's A positive. If you see only an A flag, this person's A negative. So let's look at this next one. Let's look at this guy over here. He only has a B flag. So what is this person's blood type? They are B negative, right? What would B positive look like? B positive would have a B flag and the D flag. So B positive would look like that. It would have two different antigen flags. The B flag signifies that it's type B, and the D flag signifies that it's positive, okay? So based on the flags that are on the surface of your red blood cells, you can tell which type of blood you have. Now, what about this one? It's got A, B, and D. So this person is AB positive, right? And then down here, we have somebody with just A and B, no D. They are AB negative, right? So now our last group are going to be the O's. So remember, if you are O, you don't have any flags for A. You don't have any flags for B. So here's this lonely red blood cell, and it has no flags. So if you see no flags at all attached to your red blood cell, you are O negative. But if you do see a flag attached to your red blood cell, that is the D flag, then this person will be O positive, okay? So you'll notice here that the O negative has no antigens at all on its surface. So the antigens are what cause immune reactions and what cause blood transfusion reactions. So because O negative has absolutely no flags, no agglutinogens on the surface of the cell, this is the universal donor. You can give this blood to everybody. It never causes a reaction. So the universal donor is your O negative. And the reason it's the universal donor is that it has no flags on the surface. So there is nothing here for the immune system to read and have a reaction to. When your immune system is having a reaction to something, it's reacting to the flags. It's attacking the flags on those foreign substances. So if O negative has no flags whatsoever on the surface, the immune system won't even notice that it's there, because that's how your immune system works. It reads those flags on the surface. So let's go back to the more complicated chart and let's see if it makes more sense to us now. So remember, this is our red blood cell, and this red blood cell has flags for A and flags for B. So what is this person's blood type? They are AB. And remember, if they were going to be AB positive, we'd have to add an additional flag, the D flag. That's what would make them positive. Okay? Now, what about if you're type B? What flags are we going to see on the surface of your red blood cell? We're going to see the B flags. If you're type A, we're going to see the type A flags. And if you're type O, we're going to see no agglutinogens, no flags on the surface of your cell for A or B. Now, remember, if you're O positive, you will have a flag. You will have the D flag, okay? So that's our agglutinogens. And remember, agglutinogens is just a fancy way of saying antigens, okay? Agglutinogens refers to antigens that are on the surface of red blood cells that are specifically associated with blood typing. Okay, so we got the gist of that. Now let's talk about how your immune system works. So every cell in my body will have flags on the surface to say they're mine. So my name is Jennifer Hughes. So there is a specific marker on the surface of all my cells that my immune system recognizes that all of these flags belong to me. So these are all flags that are self. Okay, so if my immune system cell comes along and it reads one of these flags, it's going to say, okay, that's a Jennifer Hughes cell. That's a keeper. It's a good one. It's a healthy cell. We want to keep that one. Now, if I ever get invaded by a pathogen, something like Staphylococcus aureus, now my immune system cell is going to read the flag and notice that this is foreign, or sometimes we say non-self. So if your immune system ever sees something that is non-self, not yours, it will attack it and kill it. And the way it attacks and kills, and the way that it helps to get rid of this foreign pathogen, is that it makes an army of antibodies. Okay, so this is how your immune system works. If it sees anything foreign, if it sees anything non-self, it makes the antibodies which help to attack and kill that foreign chemical. Okay, so blood typing works like this as well. So think about it. If you are type A, your red blood cell is going to have antigens that are type A on the surface of the cell. So this person is type A, okay? And this blood is from a person who is type A. And we know they're type A negative because it only has the A flag. It doesn't have a D flag, okay? Now the question is, can we take this blood and put it into somebody who is B negative, okay? So we're asking the question, can we put this A blood into a person who is type B? So if we look in the blood of a person who is type B, their red blood cells will have markers that say B. So what does their body think is normal? Their body thinks that seeing a flag that is B is what's supposed to be there. So if you put the A blood into this B person, they're going to make an army of antibodies. So we call these anti-A antibodies, and the anti-A antibodies will attack the foreign blood. So if you put A blood into a B person, the antibodies will attack that foreign blood, and it causes the red blood cells to clump together. So this clumping is a problem because remember, blood vessels are only so wide. So if you clump the blood together, and remember, if you put in the wrong blood in a blood transfusion, you're going to get clumping in a mass scale. Every blood vessel in the body is going to get clumps inside. So that blocks the blood vessel. And then the person dies because they have a heart attack or a stroke because their heart or their brain is not getting enough oxygen. So can you see how it works? The antigen flags on the surface of your red blood cells have to match up, because if you put A blood into a B person, this B person will think that those those A flags are foreign or non-self, and they make the antibodies that attack and kill that foreign blood. And the way the antibodies work is by clumping the cells together like this. So the clumps are what kills you. The clumps blocks your blood vessels in your brain and your heart, and you get a stroke or you get a heart attack. So let's start thinking about the agglutinogens and the agglutinins that are present in each blood type. So let's do A positive first. So what would the agglutinogens look like on an A positive person? So they'd have an agglutinogen for A and D. This says they're A, this says they're positive. So that's their agglutinogen. And then what antibodies would they have? So they're going to hate B. So they will have antibodies, agglutinins, that are anti-B. And that's going to be it for the A positives, okay? So they're going to have antibodies that hate B. So can I put B blood? These are going to attack the A blood, or if I try to put A blood into a B person, or if I try to put B blood into an A person, both of those are going to give me reactions because of these antibodies. So if I'm A positive, I can never get any type of blood that has some type of B in it, okay? Because I have an army. This is an army that attacks B. So if I put B into A positive, the army's going to attack and the clumping will happen. All right, so it is a bit confusing, so let's try and stay on target. So what about agglutinogens for A negative? So this is only going to have A agglutinogens. It's going to have antigen flags for A, and then it's going to hate the Bs. So it's going to have an army that's anti-B, and it's going to hate positive. So it also has an army that's anti-D. Right? So remember, D is the signal for positive. So we're getting into our second rule of blood typing here, which we'll talk more about when we get to transfusions, which is you can put negative into a positive. You cannot put positive into a negative. So here's why you can't put. You see that if you put A positive blood into A negative people, they have an army here that will attack the positive flags and clump that positive blood. So you cannot put positive into negative. All right, let's do B positive. That's going to have antigen flags for B and antigen flags for D. That means B positive. And then it's going to hate the A's. So it's going to have the army of antibodies that are anti-A. Okay? And then B negative. And B negative is going to have just B antigen on the cell. And then what antibodies is it going to have? It's going to hate the A's. So it's going to have antibodies that are anti-A, but it's also going to hate the positives. So it's also going to have antibodies that are anti-D, right? So you can see how this is going. Now, if you're AB positive, you're going to have flags for A, you're going to have flags for B, and you're going to have flags for D. So you have all three flags. So AB positive people are kind of weird because they have no antibodies. So they are called the universal acceptor. Remember, if there's no army to attack, there is A positive, because you can get A blood, B blood, D blood, positive blood, negative blood. You can get it all. So AB positive is great because there are no armies, no antibodies, and you can get all the blood types. It's great to be AB positive. All right, what about AB negative? They'll have the flag for A and the flag for B, and that's it. So they're going to have an army that hates the positives, though. So if you're AB negative, you cannot get any positive blood types because you have an army of antibodies that are anti-D, right? Now, how about O? This is where people tend to get confused when we get to O. Remember, O has no flags on it for A or B, but O positive must have the D flag. The D is what makes a blood type positive. So the O positive will have D flags. So that means it's going to hate A blood. It's going to have an army of antibodies that are anti-A. It's going to hate the B blood. It's going to have an army of antibodies that are anti-B. And then that's going to be it for that one. And then our last one, O negative, I'm kind of running out of space. But remember, that will have no flags. So it's got none for agglutinogens. It's got no flags on the surface. So this is why O negative is the universal donor. Because there are no flags, there is nothing for the immune system to notice. So the immune system reads those antigen flags that are on the surface of the cells. So if there's no flags, there's nothing for the immune system to read. Now, the problem with being O negative is that you have an army of antibodies that hate A, you have an army of antibodies that hate B, and you have an army of antibodies that hate the D, the positive. So you're going to have anti-A antibodies, anti-B, really running out of space, and anti-D, right? So you've got antibodies against all the other blood types. So what's the only blood that a person who's O negative is going to be able to get? O negative. So it's bad to be O negative because we may run out of blood for you, but it's good to be O negative because you can be a good citizen donating lots of blood, and we always need O negative blood. So remember, when the blood clumps, we call that agglutination. And that's what happens when you give somebody the wrong blood. Their blood clumps together because the antibodies, see the little Y's here, they attack the foreign blood, and then they clump the blood together to try and kill it and to try and get rid of this wrong blood or foreign blood. So this is what kills the person, the clumping. When the blood clumps together like this, it's going to block the blood vessels, and then the person's going to get a stroke if the blood vessels in the brain are blocked, or a heart attack if the blood vessels in their heart are blocked. So it's very serious to give somebody the wrong blood type. You will kill them. All right, so in our next video, we're going to continue and learn about blood transfusions.